Hi everyone, welcome to another one of my videos. This morning we're going to discuss some questions on methods of purification and analysis. The past paper compilation that I used in this video is downloaded from savemyexam.co.uk. I recommend this website if you need resources to prepare for your exams. Question 1. How can a pure sample of barium sulfate be obtained from barium carbonate? So we start with barium carbonate and we want to make barium sulfate. Now barium sulfate is insoluble, barium carbonate is also insoluble. So we cannot just directly react barium carbonate with sulfuric acid, because if we react barium carbonate with sulfuric acid, they will react only on the surface where the sulfuric acid is in contact with the solid barium carbonate. So what happens is a layer of barium sulfate is produced on the outside. Barium sulfate is insoluble, so having a layer on top of the barium carbonate will block the access of the sulfuric acid from the remaining barium carbonate. So the reaction will give you some barium sulfate, but it will not be pure because there will still be barium carbonate that has not reacted. To make pure barium sulfate, we have to convert barium into a soluble barium salt and then react that with sulfuric acid. So we can react barium carbonate with hydrochloric acid. That will give us barium chloride, which is soluble. And then later add sulfuric acid to get barium sulfate solid. And then filter and wash. Now we don't need to crystallize because the product is already a solid. Crystallization is used when we want to get the salt crystals out of a salt solution. Question 2. Which property of liquid esters can be used to check its purity before use as a food flavoring? So checking purity can be done by measuring the melting point or the boiling point. This goes for any substance. If the ester is pure, then the melting point and the boiling point will be sharp, and it's exactly as the pure ester, or we call as the standard. But if the ester is not pure, it will melt or boil at a range of temperature. Question 3. In which method of separation are RF values used? RF values are used in chromatography, like for example in paper chromatography. For example, we have one sample that gives only one dot. So the RF value of this substance here is just the distance traveled by the substance, let's call this A, divided by the distance traveled by the solvent, let's call this B. So RF value is A divided by B. Question 4. The apparatus shown is used to distill a dilute solution of ethanol in water. This is a setup of fractional distillation. It's usually used to separate liquids with different boiling points. Which graph shows the change in concentration of the ethanol in the boiling flask, or this round bottom flask, as the distillation proceeds? Because the boiling point of ethanol is lower than that of water, so it's the ethanol that's going to be distilled out first. So this conical flask will all be ethanol. This means that the concentration of ethanol in the boiling flask actually decreases. So the answer is C. Concentration of ethanol decreases until it's zero, because all the ethanol has been distilled and moved into the conical flask. Question 5. The diagram shows the fractionation of crude oil. Which row explains why fraction R is collected above fraction S? The fraction at the top of the fractionating column have shorter carbon chain or smaller molecules. And because they are smaller, the intermolecular force is weaker. And therefore, boiling point is low. So R is above S. That means R must have lower boiling point than S, and the average molecular mass is smaller than S. Answer is D. Question 6. A mixture of substances is spotted on a piece of chromatography paper. This paper is inserted into a beaker containing a liquid. For separation of the substance to occur, the spot of mixture must, so this sample must be above the solvent. So the paper must be positioned something like this. If the spot of mixture is submerged in the liquid, it will just dissolve into the liquid and not up the chromatography paper. Okay, so the spot of mixture must be placed so that it's above the level of liquid. And it must be soluble in the liquid. Yes, this is true, because if it's not soluble, the spot will not be traveling up. It will just stay where it is. Contain substances of the same RF value? No. Contain substances that are colored? Not necessarily, because as long as the substances are soluble in the liquid used, we can separate the mixture. Now, what if the substances are not colored? Then we just spray with locating agent or view under UV light. And that will enable us to see the spots and measure the RF values. Question 7. It is suspected that a lollipop contains traces of poisonous green dye, boiling point 73, as well as 2 harmless orange and red dyes, boiling point 69 and 73. What is the best method by which the green dye may be detected? Because the boiling points are very close to each other, and even the same for red and green dye, we cannot use fractional distillation. And besides, a lollipop has a small amount of dyes, so it cannot be separated using fractional distillation. Also cannot be separated using filtration, because filtration is to separate solid from liquid. So it cannot be used to separate dyes. Paper chromatography is more like it, as long as these dyes have different solubilities in the chosen solvent. So answer is C. Recrystallization is a method that is used to purify chemicals based on their different solubilities, but it works with higher amount of sample. Question 8. Copper 2 sulfate crystals are separated from sand using 4 processes listed below. In which order are these processes used? Copper 2 sulfate is soluble in water, whereas sand is insoluble. So we can dissolve copper sulfate first, and then filter the sand out, and then evaporate the water and crystallize the copper 2 sulfate back. So answer is D. Question 9. Oxygen was prepared from hydrogen peroxide with manganese 4 oxide as the catalyst. The oxygen was collected as shown in the diagram. The first few tubes of gas were rejected because the gas was contaminated by nitrogen, because air is composed of 78% nitrogen and 21% oxygen. So this 78% nitrogen was in the flask before the reaction happens, and it's going to be moved or pushed into the tube here and contaminates the first batch of gas produced. Number 10. The two statements are about fractional distillation of crude oil. Statement 1. Fractional distillation is used to separate crude oil into useful fractions. This is correct, and it works by heating the crude oil, and the fractions will just separate based on their differences in boiling point. The one that has lowest boiling point will be collected at the top of the fractionating column. Statement 2. The fractions with lower boiling point are found at the top of the fractionating column that this is correct. So both statements are correct, and statement 2 does explain statement 1. This is how the separation works. So A is the answer. Question 11. The boiling points of various gases found in the air are shown below. If the air is cooled, the first substance to condense is water. If the temperature is lowered further, what is the next substance to condense? So the first substance to condense is gas to liquid. So that means the first substance to condense is the one with the highest boiling point. The next highest boiling point is carbon dioxide. So answer is B. Question 12. The diagram shows a chromatogram of several inks. Which statement is correct? Statement A. Black ink can be made by mixing green, red, and yellow inks. So what do we have here? So black ink has the same spot here with this one, but it's missing this spot. And this is the same as this. Alright, so it looks like black ink has green dye, but it's missing one component from red dye. It does have yellow ink though. Okay, so this red is not there. How about brown ink? Can be made by mixing blue and red inks. Brown has the same spot as one component of red and both component of blue. So blue is there, but red is missing one component. C. Yellow ink can be used to make brown ink. So yellow ink and brown, but brown is missing that component from yellow. So this is incorrect. D. Yellow ink may be present in green ink. And that is correct because the two spots here have the same RF value. So the answer is D. And it says may because even though the RF value is the same, but the component may not be the same. But those two components have exactly the same solubility. They may not be the same compound though. Question 13. The table gives the properties of 4 substances. Which one is a solid metal at room temperature? Most metals have high melting point, but not always. But what's always true for metals is that they conduct electricity both in solid and molten form. So these two are metals, and only B is solid at room temperature because it melts at 98 degrees. Whereas D melts at -39. So that means at 25 degrees Celsius, it's a liquid. Question 14. How is the RF value of the dye calculated? RF value is the distance traveled by the dye divided by the distance traveled by the solvent. So that means it's Y divided by X plus Y. This point here is called the origin, and that is where the spot of dyes or your sample is applied. So the distances must be measured from this level, not from the level of solvent, but from the origin where the dye or sample is applied to. Question 15. Which elements must be gaseous at -190 degrees Celsius? For the element to be gaseous at -190 degrees Celsius, its boiling point must be lower than that temperature. So maybe let's say the boiling point is here. All right, so this would be a greater negative number than 190. So helium, neon, nitrogen, they are all gaseous because they boil at a lower temperature than -190 degrees Celsius. Whereas argon boils at -186 and oxygen boils at -183. So nitrogen and oxygen at -190 degrees Celsius are still in liquid form. So the answer here is C. Question 16. Which method could be used to obtain charcoal from a mixture of powdered charcoal with sodium chloride? Powdered charcoal is insoluble in water, whereas sodium chloride is soluble in water. So if you want to obtain charcoal, you can add water to dissolve the sodium chloride and then filter the charcoal. The charcoal will be the residue. So answer is B. Question 7. Which property shows that a liquid is pure? Option A. It turns anhydrous copper sulfate blue. This tells us that the liquid contains water, but it doesn't tell us whether or not the water is pure. Because as long as there is water there, then anhydrous copper 2 sulfate will turn blue. Colorless and odorless liquid is not always pure because if there is a dissolved solvent that is also colorless and odorless, then it's impure. So color and odor does not tell us if a substance is pure. It has no effect on red or blue litmus paper. This just means that the substance is neutral. It doesn't mean that it is pure. It boils at a fixed temperature at a given pressure. This is the correct answer. A pure substance boils and freezes at a fixed temperature. By fixed temperature, it means that at one temperature, the whole substance will boil off. So if we're dealing with a mixture, let's say salt solution. So this means we have water, we have a lot of water and salt dissolved in the water. So our water is impure, right? So this impure water could boil, let's say it starts to boil at 103 degrees Celsius and it finishes boiling at 105 degrees Celsius. So this is not a fixed temperature. This is a range of temperature. Fixed temperature, if it's pure water, it will boil at exactly 100 degrees Celsius. Question 18. A test tube containing a liquid X is placed in a beaker of boiling water. The liquid X starts to boil immediately. What is the boiling point of liquid X? So because as soon as liquid X is placed in boiling water, it starts to boil immediately. That tells us that the boiling point of X must be lower than the boiling point of water, but it must be higher than 25 degrees Celsius because at room temperature before it was placed in boiling water, it was a liquid. That means this is at 25 degrees Celsius. So answer is D. Question 19. Which test could be used to show that a sample of water is pure? Again, to test for purity, you can measure melting point or boiling point. For water, it freezes at exactly 0 degrees Celsius, a fixed temperature, and boiling at 100 degrees Celsius. So answer is A. Options B and C. These are tests for the presence of water, not for testing the purity, but for testing if water is present. Question 20. This is called the cooling curve. So we start at a high temperature and from Q to R, there is no change of temperature. This is when there is state changes. All right, according to the question, we start off with a liquid. So P until Q here is liquid, and when this hot liquid is cooled down, liquid to solid, and this is in equilibrium. This is called freezing, and the rest of the curve shows a solid form. So when are liquid and solid both present is between Q and R. C is the answer. 21. Which of the following is a pure compound? Ethanol is a pure compound. Petrol is a mixture of different hydrocarbons. Steel is an alloy, which is also a mixture. Steel is a mixture of iron and just a tiny amount of carbon. Tap water is also a mixture because there are a lot of dissolved ions in tap water. Question 22. Substance X melts at 53 degrees Celsius and boils at 100 degrees Celsius. It does not dissolve in water and it does not react with water. Which diagram shows the method most suitable from separating X from a mixture of X and water? X at room temperature is a solid. It does not dissolve in water and it does not react with water. So how do you separate a solid from water? You just have to filter it. The best method to separate X from water is by filtration. Option A is called simple distillation, and it is usually used to separate the solvent from the solution. So the solvent will evaporate first and then condense in the condenser and then separates out into the conical flask here, right? Whereas the solution remaining will be more and more concentrated over time. Or simple distillation can also be used to separate two liquids with a large difference in boiling point. Option B is called fractional distillation. And this is a better way to separate different liquids with different boiling points. Question 23. Which of the following is the best method of obtaining pure water from ink? Ink dissolves in pure water. So to separate the solvent from the solute, we have to do distillation. B is the answer.
24. The diagram shows the chromatogram of 4 different sugars using the same solvent. Glucose has an RF value of 0.5. Which sugar is glucose?
To remind you, RF value is the distance traveled by the substance divided by the distance traveled by the solvent. So if RF value is 0.5, the distance traveled by the substance must be half the distance traveled by the solvent. So in this case, the one that is half is C. This distance is half that. So RF value must be 0.5. If the substance travels as much as the solvent, then the RF value is 1. So the highest RF value is 1. The lowest RF value is 0. And that is when the sample is insoluble and it does not move up at all. That's when the RF value is 0. So the answer here is C. Question 5. A liquid boils at temperature 100 degrees Celsius. Which other property of the liquid proves that it's pure water? So again, purity can be measured by measuring the boiling and melting points, and they must boil and melt at a fixed temperature and at the temperature of the standard. Okay, so standard pure water boils at exactly 100 degrees Celsius and freezes at exactly 0 degrees Celsius. So B is the answer. Question 26. The equation for the reaction between lead to nitrate and aqueous potassium iodide is shown. Which method could be used to separate the products? We have two products. One is a solid and the other one is an aqueous solution. So to separate solid from an aqueous solution, we need filtration. Question 27. The most suitable way of investigating the different food coloring in some drinks, and this is done by paper chromatography. Okay, that is all for today. Thank you for watching. Bye.